Hello and welcome to this Python tutorial on how to deal with categorical variables when you're working with different types of modeling techniques. So let's just take a second and review really quickly what I mean when I say categorical data, which I imagine you know, but I don't want to assume. So we have different types of data that we can deal with when we're working with business modeling. So you'll see we've got several different types of numerical continuous values that are happening over here that are either an ordinal scale or just a continuous numerical scale. They're just basically counting upwards, things like age, for example. But you'll see as we look at our IBM data set here that we also have things like marital status, which is single and married, and hopefully not, but there might be a divorced in here. And we see things like the department where we've got sales and research and development. Okay, these are different types of categorical variables. Okay. So when you're dealing with categorical variables, we can use them when we work in our different types of modeling techniques. And specifically, as we start to transition in naive Bayes, the only thing you can use with naive Bayes is categorical data. But that being said, we still don't like words. Just in general, most things you deal with in the world of computers just don't like words. So even though we do want categorical data to go into naive Bayes or other areas of machine learning that we're going to work with, we don't want to put them in actually as words. So what we have to do is we have to do some kind of pre-processing. We have to do some kind of transformation that takes the words, for example, single or married or female or male, and converts them into numerical values that represent whatever that would be. Now, depending on the nature of the data, if it's ordinal or if it's nominal, you can go through and you'll either label encode it or you'll OneHot encode it. Just sort of depends on what you're doing. So what I wanted to do was take a little bit of time today and talk to you a little bit about label encoding, talk to you a little bit about OneHot encoding, and show you exactly how those things all work. So I thought I'd start off with just basic OneHot encoding. And there are a couple different ways to do that when you're working inside Python. A couple different libraries can do it. So the most basic way of OneHot encoding is actually just using pandas, which you've already got pandas loaded because we use that to load the data frame, which you're looking at on the screen. And if you're in class with me and you want to follow along, I'm actually using the IBM employee data set that's available for you on Canvas. So feel free to pause this video, grab that from Canvas, load it up, and meet me here. Okay. So let's just start off with a basic challenge. So we have our gender column here. And in this gender column, we have two unique values. We can look at them. Okay. So if we do df gender dot unique, we can see there are two unique categories inside this, female and male. All right. So we want to use those in our predictors. Or we want to use those as a predictor. So in order to do that, we're going to need to change the words female and male to something else, like 1 or 0 or 1 or 2, depending on how you look at it. Now, 1 or 2 is not the best choice here, and that would be an example of label encoding, which we'll talk about a little bit later. In this particular instance, since it's two nominal categories, the best thing that we could do here would be to OneHot encode this data. So I want to show you how to go about OneHot encoding. So the first way we'll do that is with pandas. Okay, so OneHot encoding with pandas is actually really, really easy. I'm just going to declare a variable called dummies. Okay, and inside that, what I'm going to do is I'm going to go pd.get dummies, and I simply need to tell it what category or what column from my data that I want to actually be dummy coded. Okay, so now if I do this, all of a sudden, you'll see that we have that. So let's talk about what we've done here when we talk about dummy coding. So what dummy coding has done is it's exploded the gender column here. Okay, so it's taken it, and for each category that shows up, or each class, if you want to call it, inside this different column here, it has created a new column specifically for that one category. So we've just got female and we've just got male. So inside the only female and only male columns, what you'll see is you've got a 1 if that person was a male, and a 0 if that person was a female, or excuse me, 1 if that person was a female, and a 0 if that person was a male, right? So 1 indicates positive, 0 indicates negative. So this person was female, this person was not, this person was not, this person was. So it's basically converted this into a method of using numbers so we don't have those words working in them. So OneHot encoding basically uses binary to tell you a class membership. And when it does it using getDummies, it actually explodes the single column right here into multiple columns, one column for each different category that lives inside that column. So if there were two categories, right, there were two unique values. That's what we saw here, female, male. So there's two columns, male, female, okay? So now is probably a good time to briefly say that when you work with getDummies, you actually have to avoid something called the dummy trap. So exactly what is the dummy trap? So the dummy trap deals with something called collinearity. And if you look at this particular example, right, female, male, what you'll find is we don't actually need both of these as predictors. We really don't. Because if you look at just the female column, so say that male column just completely goes away, like say we drop that column. If you were to look at the female column without looking at the male column, you would still be able to determine if the person was male or female, right? Because by default, if they're female, then they're not male. And if they're not female, then they are male. So you really don't need both of these because they're predicting the same thing. And another way to look at it is saying they're basically collinear. So as one changes, the other one's changing. So we don't want that. We would actually want to drop these. Okay, it's a really common thing called dummy trap. If you were to go out and Google it, you'll probably find a million examples explaining it probably better than I did. But ultimately what you want to get is when you're dummy coding, you need to drop one of the variables so you don't have two variables predicting the same thing or more. Okay, so the good news is with the getDummies method that's included inside pandas, there's actually something built in called drop. Okay, so I can go in and I can say drop first equals true. And when I do that, all of a sudden, hey, I've dropped one of the columns. So now what can I do to make this even better for you guys, right? Because right now it just says male. Well, I could really easily go down here and I could simply rename this column. So I could rename male to gender. And we want to use the axis equals columns in place equals true. And now if we look at dummies, there we go. We've got something we can work with. So this is good. This is a good thing. Okay. Perfect. So that is an example of OneHot encoding using pandas. So what makes things a little bit more interesting is that getDummies, as good as it is, has some flaws. Okay. And because of some of the flaws, you'll find that depending on what you're doing, you wouldn't necessarily want to use getDummies. And there's a lot of reasons why. So for example, getDummies doesn't really have any kind of error handling. getDummies doesn't actually save the variables in any kind of memory or anything. So for example, if you're doing, say, a train test split, or if you're looking at actually using your model for something, and you need to OneHot encode the data that you're going to run through your model actually to use as predictions, well, you could get different values if the data that you're actually passing in doesn't have all of the original classes that are in the training set, for example. So you could actually get different types of dummy coding, if that makes sense. So what you'll find is that if you're doing something more complex, you may not want to use getDummies. Now, getDummies is super easy, right? So it's literally just getDummies and then tell it what column you want and to drop the first the first class within that exploded column. So it's really, really easy to do. And if you can get away with it, I mean, I do, if it's something that doesn't require anything super robust. But in the event that you do need something a little bit more robust, then in this case, you have to use the OneHot encoder, or you'll need to use sklearn's OneHot encoder. So let's talk about that a little bit. So first of all, sklearn has a variety of pre-processing tools that are built into that library. It's really, really helpful. So what I'm going to do is I'm going to go to my sklearn, sklearn.preprocessing. And from pre-processing, I am going to import the label encoder, which we're going to use in a little bit. And I'm also going to include the OneHot encoder, which we're going to use now. Okay, so let's just run that again. And let's talk about it a little bit, okay? So what can you do with the OneHot encoder? So we can do the exact same thing that we just did before, but what makes it special is you actually fit the OneHot encoder to your training data. So because you fit it to the training data, it actually is going to look at all of the classes that are inside your data sets, inside each one of those columns. And even if you don't need each one, it's going to give you a column for it anyway, in the event that you say do all the things that wouldn't work very well with dummy coding or with get dummies. Okay, so let's just sort of jump right in, take a look, and we'll see exactly how this thing works. So the first thing I'm going to do is I'm going to do a variable for my encoder. So we're just going to go encoder, and that's going to be OneHot encoder. Now, what we want to do here is that we need two different things that happen. So we want this thing to come out as a NumPy array. So what we're going to do is we're going to take the sparse output and we're going to make that true. And then we still want to drop that first column. So we want to pay attention to that dummy trap that we just talked about. So I'm going to do drop equals first, and then we're going to run it. Okay, so one gives us a NumPy array output, and the second one makes sure that we drop one of those categorical variables within that dummy coding to make sure we don't have the dummy trap. So that's a pretty good deal. Okay. So the next thing we want to do is we want to fit and transform the data. Okay, so I'm going to create yet another variable, which we'll call, just for example, the x, for the x variable, encoded. Okay, and from there, we're actually going to call our encoder, and we're going to use dot fit and transform. Okay. And from there, we can literally just pass in the column that if we wanted to, right? So we could just say df gender like so. Now we're not quite done because we want this to go to a NumPy array. So we'll go to array like so. So now we should be able to take a look at this and see what we've done, but it probably won't be the way you want it to be. Cool. So when we take a look at it right now, we do actually see the array of dummy coded data, right? So it should be exactly the same, right? See it up here, 0, 1, 1, 0, 1, 0, 1, 1, and then it kind of stops and it gives us the last three. So that is what we want, except it's giving it to us in a NumPy array. So because it gave it to us in a NumPy array, you probably don't want that. You want it in a data frame so you can see it, use it for training, any of those things. Not a problem. We can use the data frame method from pandas in order to get this array into a data frame. So here's what we're going to do. We're going to create a new variable for a data frame. So we'll call it x encoded data frame. And we're going to use that data frame method. So we'll go pd.data frame. Yep. Okay. So we've got all that going. So what we want to do is we want to take our NumPy array and pass that in first. Like so. Now, if I just let this go, it might yell at me, but what we really want to do is we want to give it column names. Let's see if we can do it. Yeah, if we just let it go, it actually is going to work, but it's not going to give us exactly what we want. So it gave us a data frame, but notice that it gave us a data frame that didn't have an actual column name to it. It just gave us 0, and there's all of our data. So we could make this a little bit better by specifying the column or the column names using the encoder. So what we're going to do is within that data frame method, we're going to go columns, and we're going to take this special piece of the encoder, and I'll show you the code for this in just a minute. So we'll go to sklearn's website and we'll do get feature names out. And what that's going to do, there we go, is it's going to go in and it's going to look at the actual feature name. So like it looked at the column and it said, oh yeah, this column was called male. And it's going to pull that out and give it to you as the name of the column. So at this point, you've got a data frame that is OneHot encoded. You've avoided the dummy trap, and you are ready to go. So perfect, all good. Okay. So the next thing I wanted to touch on really, really quickly, and I feel like I'm moving fast, so I'll probably end up redoing this video a little bit later, is I want to show you how to do label encoding. So label encoding is just a little bit different. So to show you, let's go back and look at our data frame for a second, or actually we'll just pull it down here. So inside our data frame, we have an option in here called business travel. And inside there, I'm going to use this term loosely. We're going to say that this is ordinal data inside the business travel column. And what it's telling you is how much you travel. So you either travel rarely, you travel frequently, you travel not at all, or you travel a lot. Okay. And if you want to isolate that and see exactly what it is, well, we can do that. So we can go df.business_travel or df business travel dot unique. And it should tell us, okay, we either travel rarely, travel a lot, or we don't travel at all. So we could argue that this is indeed ordinal data. So with ordinal data, it's kind of interesting. So remember, we use dummy coding to indicate nominal data categorical or nominal categorical data. And the reason we did 0 and 1, basically we binary coded this, is because we didn't want to show it any kind of ordinal relationship. So we didn't want it to think that one was better than the other. But in this particular case, there is an ordinal level here, right? So you either don't travel at all, you travel a little bit, or you travel a lot, right? So in this case, we could encode this with 1, 2, 3 instead of into one column, instead of having 3 columns that are 0 or 1 encoded. Okay. So in order to do that, instead of using the OneHot encoder, we have the option of using the sklearn label encoder, which if you go back, we pulled that library in as well. Okay, so let's go down and take a look at the label encoder and see how that works. So the first thing I'm going to do is just create a variable called LE, and we're going to assign to that our label encoder from sklearn. And this one's pretty easy. Okay, so once we assign that, the next thing we want to do is we want to tell it exactly what we want to label encode, and then figure out where we want to spit that thing back out. So let's look at what we're going to do. So we're going to create, I'll keep it simple. So I'll create a new data, or I'll create a new column for our data frame. So we'll go df encoded, or we'll go df label encoded. Okay, so we're going to create a new column inside our data frame that we've already got. And in order to do that, we're going to take our label encoder and we're going to fit and transform the df business travel column like so, but without the extra quotation marks. So now if we do this correctly, here's what you're going to see. Perfect. So if I look at my data frame, I go all the way to the end, you'll see I now have a new column called label encoded. And inside that label encoded, you'll see I've got some numbers in there now. So I've got 1, 2, and there should actually be a 0 in there as well. We should be able to explode this a little bit and see it better. So I should be able to do df label, or actually we'll do df, you think I'd remember what I just called it, df label encoded dot unique. And there you go. We've got 3 variables, right? So we had 3 different options inside here, which was travel a lot, travel a little, or don't travel at all. And it has been encoded into 2, 1, or 0. And that's how it works. So it's not meant to be horribly difficult. Hopefully this helps you get started in the world of categorical data. What I just want to stress to you is, as you start to proceed and you work with k-nearest neighbors and you work with naive Bayes, it's okay to have categorical data. We want it. We don't want to not have that valuable information. But know that words are almost always bad. So you wouldn't just be able to pass in an unprocessed piece of data into one of your algorithms and try to get that to actually work. So make sure you pre-process that either using OneHot encoder, get dummies, or the label label encoder in sklearn, and you'll be happy and on your way to your next great data model. So I hope this helps you. I hope you enjoy it. Of course, I'm happy to help. If there's any questions, feel free to let me know. Like those young people out there say, like and subscribe. I just do this because I enjoy it. We don't get a ton of people that actually watch these videos. So thank you for sticking with me till the end. And I hope to see you in class or see you online sometime soon.